All right, welcome back. We're doing inverse functions today, and we're going to take a moment and we're going to talk about what's the difference between a relation and a function. Basically, a relation in the math world is anything that fails that vertical line test. So something that might look like this here, that's a relation, not a function, because it fails the vertical line test. The vertical line test is just if I could put a vertical line through it and it crosses in more than one place, then it's not a function. So we have relations and functions. Relations pass the vertical line test, and functions do not pass the vertical line test. When we talk about inverse relations, what we're talking about when we say inverse is basically the inputs or the domains. The inputs switch places with the outputs. So the inputs and the outputs interchange positions or switch or whatever word you want to use there. Basically, it's reflected over the y equals x axis. So the inputs and the outputs switch. Okay? And if it's an inverse function, that would mean that the function and the new function created when you switch the inputs and outputs, both of them would pass a vertical line test. Some people like to call that one-to-one. We'll talk about that in a little bit. It says find the equation for the inverse of the relation y equals 7x minus 4. Well, we know it's not just a relation. It's a function y equals 7x minus 4. All you have to do, switch the x's and the y's. And so now x equals 7y minus 4. And solve for y. So we're going to add 4 to each side, and we're going to get x plus 4 equals 7y. And then we're going to divide both sides by 7, and we get x plus 4 over 7. So the inverse of the function y equals 7x minus 4 is y equals x plus 4 divided by 7. Those are inverse functions of each other. The one thing we know about inverse functions is that if we take the composite that we just learned about in the last lesson, if we take the composite of each function, f of g of x has to be x, or g of f of x has to be x, if g of f and f of x are inverses of each other. Therefore, if I ever get x when I'm doing a composite, I know that those two things were inverses of each other. On example 2 here, we're going to verify, which is another word for this is going to happen, but just show yourself why it's going to happen, that f of x and f inverse of x are inverses of each other, besides the fact that it actually says inverse right there. So what we're going to do is find f of 1/7 x plus 4/7. And I look at function f, and if that's going to be my new x, then I'm going to do 7 times 1/7 x plus 4/7. And if I do 7 times all of that stuff, whoop, whoop, don't forget I got to subtract 4 from it eventually, I'm going to get x plus 4 minus 4, which equals x. Yes, in fact, it is an inverse. And it works the other way just as well. This one's a little more difficult, but we have 1/7 times 7x minus 4 plus 4/7. And if I give it a whoop, whoop, I get x minus 4/7, 1/7 times 4, plus 4/7. And I get an x because those cancel each other out. And therefore, I've verified that we, in fact, have inverses. You guys go ahead and do checkpoint there and see how you do. All right. So you had to take this one and find the inverse of it. Hopefully you did. What I did is instead of f of x, called it y equals negative 3x plus 5. That's the easiest way to do that. And then you flip-flop the x and the y. X equals negative 3y plus 5. And you go through your steps and you solve for y. So you just subtract 5 on both sides, subtract 5 on both sides, and then you divide by -3. So y equals x minus 5 divided by -3. All right? Let's take a look at example 3 there. In example 3, you're trying to find the inverse of 4x squared. Well, again, just switch the x and y and solve for y. So we're going to divide by 4. We end up with x over 4 equals y squared. And then I square root it, and I end up with the square root of x divided by 4 equals y. X divided by 4 equals y. So when you add the square root of x over the square root of 4, obviously that's the square root of x over 2. So y equals the square root of x over 2. The domain of f is restricted to the negative values of x. If you take a look at y, is restricted to the negative values of x, so the range of f inverse must also be restricted to the negative values. And therefore, the inverse, f inverse of x, which we know is going to be -1/2 times the square root of x, because of that whole negative value thing. If the domain were restricted to x is greater than 0, then we would just have 1/2 x. Now let me explain that for a minute. I don't know if I did a great job explaining that the first time around. When I squared both sides, we had the positive and the negative x that we could have used. But in our scenario here, the only values that could possibly work for us and pass the orders of operations, or I'm sorry, pass the vertical line test, are the negative values. And so when I put the negative values in there and I graph it, you're going to see something a little different. So let's go ahead and put that into our calculator for just a minute. And so what we were graphing, remember, was y equals, let's turn it on. Y equals, and what we were graphing was either 1/2 the square root of x or -1/2 the square root of x. We're going to do -0.5 times the square root of x. And we're going to get this graph. And the graph looks just a little bit funky there. So this graph right here, when you take a look at it, it is the reflection of y equals 4x squared. Now 4x squared would look something like this. It'd come around, I guess I could always graph it, but it would come around and it would make a parabola. And because it would drop down right here and hit and go back up, what we're looking at is the reflection of this thing. So watch what I do here. I'm going to do a y equals, and I'm going to do a y equals x. And that's going to give me a graph like that. And then I'm going to do a y equals 4x squared. 4x squared. And take a look at that graph. And so this piece down here is that reflection up here. So if I could kind of paint a picture for you. See that graph there? And then if I change the color so I can kind of point this out, this piece right here is the reflection of this piece right here that I'll dot for you across this line. And because they interchanged the y's and the x's, that's what happened. Now, the only way this thing would pass a vertical line test is if I only graph that bottom part. I hope that makes sense. All right. If not, I guess we can always ask that question tomorrow, which I might see a lot of, I would imagine. Let's take a look at that horizontal line test that I talked about earlier. In that horizontal line test, remember we have the vertical line test. The horizontal line test says if your function passes the horizontal line test, then the inverse of that function will also be a function, because it would therefore pass the vertical line test, is what they're getting at when they're talking about that. So if the graph, if it doesn't go by it more than once, is the words that we're looking for here, more than one time. So it can pass it once but not twice. All right. So the horizontal line test says this thing here might be a function, the parabola, but its inverse is not going to be a function, because its inverse is going to look like this, and therefore fail the vertical line test. All right. So we take a look at example 4, and they say consider the function f of x equals 1/4 x to the third plus 3. Determine whether the inverse of f is a function, then find the inverse. So the first thing I have to do is graph this function. And if you graphed it, I think you would notice it crosses right here at 3, and if you just threw it on your calculator, it would look something like that. All right. And notice that there's no horizontal line. It passes the horizontal line test. So there's no horizontal line could intersect it at any place. So therefore, or more than once anyway. So the inverse of f itself is a function. And so whatever we get for an inverse of it, it is a function. To find the equation f inverse, complete the following steps. So here's what you have to do. You have to replace f of x with y, switch your x and y, so x equals 1/4 y to the third plus 3, and then you have to solve for y again. So I'm going to do that over here. X minus 3 equals 1/4 y cubed. Multiply everything by 4. 4x minus 12 equals y cubed. And then we're going to take the cube root. So when I take the cube root of 4x minus 12, you can only imagine that's going to be a little bit of a mess. And so the inverse of this thing, of f, is right here. All right. Take a look at the checkpoint. Here are some answers for the checkpoint, and we'll discuss this some more tomorrow. Go ahead and try that real quick. Pause and try it. All right, welcome back. Hopefully you flip-flop your x and your y. Y equals 2y to the fourth plus 1. Subtracted 1. X minus 1 equals 2y to the fourth. Divide by 2. X minus 1 all over 2. And then take the fourth root of the whole thing. And you don't really need to simplify much past that. I know some of you are saying, oh, but Mr. Emeott, you got a fourth root on the bottom of a fraction. I get all that. Just leave it right here is fine. On this one, again, we're going to go x equals 1/32, y to the fifth, multiply by 32, 32x equals y to the fifth. But on this one, when I take the fifth root of both sides, the fifth root of 32 happens to be 2. So it's 2 fifth roots of x equals y. And it's as simple as that. All right, folks, a lot of challenging stuff. I know it's all coming to an end, but thank you for sticking with me. Keep it up. Have your questions ready for me tomorrow. See you then. Bye.